Hey folks, welcome back. In this class we're going to be looking at distance and displacement. So these are some words that are going to be thrown around a little bit over the course of this subject. Distance is something that we're all very familiar with, something like 10 meters, or if you ask how far away are you from school, how far away do you live, you can say, I live 5 kilometers away, that sort of thing. So distance is magnitude only. And if you remember from our previous lesson, something that only has magnitude is a scalar quantity. I'll just write scalar Q for short there. For example, 10 meters, 3 kilometers. The units of measurement are not terribly important in this case. It could be 25 light years or something like that. That's still a distance. Displacement, you may not have heard of displacement before, but just based on our previous answer, it's going to have a magnitude. And the only difference is it also has a direction. And this makes it far more useful for us when we're going to be looking at calculating certain things. Now, because it has a direction as well as a magnitude, we will call that a vector quantity. So for example, we could say 10 meters north. Okay, or 3 kilometers up. So how far did the rocket go? 3 kilometers up. That sort of thing. So there's a few things that we can do with distance and displacement, and I'll show you by way of an example. Suppose we have a dude over here, and this is his origin. So he starts over here. I shouldn't always say dude. It could be a girl, anything, doesn't really matter. But it's a person. So they're starting at this origin, and they walk 3 meters down this way. Then they might turn right, or that would be their left really, and they go 10 meters here. You can see my diagram is not to scale. That's alright. And then they come back up another 3 meters here. So this is their finishing point in orange. Now I could ask you, well, what is their total distance traveled? And what is their final displacement? And there's a few other ways that you can kind of ask these questions, but they're pretty chill. It's kind of like the ones that I'm going to be sort of asking you. So the total distance traveled is just a simple bit of maths. We walk 3 meters, then 10 meters, and then another 3 meters. So that's just going to be a bit of addition, 3 plus 10 plus 3, which equals 16 meters. Really important in this subject, and I'll be a bit of a fanatic about this, that we always include our units. It'll make life a lot easier for us. We won't stress too much about conversions, because that can throw people off a little bit. Like, they will be there, but it's not going to be big. But everything else, keep your units in. It'll make life a lot easier for you when you're chucking in different things into bigger formulas. Now, final displacement, just to give you a little bit more help, we might put in a compass here. So this might be north, never eat soggy Weet-Bix. That's how I remember it, never eat soggy Weet-Bix. So north, east, south, and west. So displacement, remember, has not only a magnitude, but also has a direction. So the direction's the easy one. He started at this origin, and he's ended up here. In this case, we've gone east. But what's the magnitude? Is it 16 meters? In this case, it's not 16 meters, it is this magnitude here. In that case, it is actually 10 meters east. So the final displacement is using the concepts of origin and relative to far more than distance is. Distance is like, you could take a huge path. You could go all the way over here, do heaps of loops and stuff. You could do 17 kilometers or whatever, and he ends up here. But his final displacement is that he's only 10 meters east. Okay? So that's a really important sort of consideration to come to when we're looking at some problems later on. Now, another way that we can do this is we have this person and they walk over here. They might walk, say, what am I thinking, 3 meters. And then they go north for 4 meters. And then that's it. So they stay there. So this is our origin in the red. And I'll just make it blue up here, which will show you the final point. Again, what is the distance? I'll just write disp for short, and I'll write disp. I'm going to need a bit more space actually for disp. I'll write disp for displacement. Distance is the easy one to do. 3 plus 4. 3 plus 4, which equals 7 meters. Always include those units for me. Now displacement, it's a bit tricky because we're actually looking, like the previous problem was just a straight line, but in this case we're looking at this sort of diagonal here. And what we have to use is Pythagoras' theorem, which if you remember it was a squared plus b squared plus c squared. I'm going to write that just here so you can see it. The formula is a squared plus b squared equals c squared. So it depends on how confident you are with Pythag. I'm going to go through like the really chill way, and like it'll take a little bit more time, it's a bit more working out. If you're super confident with it, by all means don't do all this working out, but I'll just go through the basics. So the first thing you should do for something like this is you should label where all your values are. You know, what's my A, what's my B, and what's my C. C squared is the hypotenuse. C is always the biggest value, okay? So C, it's the opposite of the right angle if you kind of want to go through that. A and B, it doesn't matter which one. This could be A, and this will be B. They could be reversed if we want, but that's all right, okay? So I'm going to carry this on. Actually, let's break it down. If this was a multi-mark question, if you said a squared plus b squared equals c squared, you would generally just get a mark for that because you're showing that you're using the appropriate formula for that. The next part is we actually put our values in. I'm going to put 3 dots here, which means therefore. You don't have to do that, but it helps me. I guess it's a bit of a habit. So therefore 3 squared plus 4 squared equals c squared. C squareds are unknown. Now we'll expand, I guess. So 3 times 3 is 9, plus 4 times 4 is 16, equals c squared. Therefore 25 equals c squared. Now, a little bit of algebra, which I know some of you don't like, but algebra is really fun actually when you get when you get a bit confident with it, it's actually pretty good. We need to get rid of this squared here. So you just have to do the opposite of what it is on both sides. In this case, we're going to take the square root of the both sides. So square root of 25 equals c squared. So therefore c, I'm just going to shift these around, equals 5. And we're going to put our unit of measurement there. Now, that's a huge amount of working out for something that some of you can probably just do in your head, but that's all right. It's your course, your learning. It's about how you sort of want to process through this. This is actually a really good habit for when we use much more difficult formulas. I mean, there's some in this course are tricky, but if you're doing physics in year 11 and 12, you get some real tricky ones. So it's always good to put your working out. It just helps you think a bit better, I think. Just put it on a space, you can have a look at it. You can always see if you've made a mistake or something like that, especially with algebra. Now, other than that, your work that you'll be doing is just going to be, first of all, classifying things as whether or not they're distance or displacement. So just getting that scalar and vector definitions back into the mix, and then doing some calculations. Other than that, peace out.